Good morning, children. Stay safely at home and complete all the study related work in time, sincerely and properly. So today I'll discuss alpha decay, beta decay and gamma decay. Now whenever and you know that this alpha decay, beta decay and gamma decay or disintegration of a nucleus through alpha emission, alpha particle emission, beta emission or gamma emission, these are completely purely a nuclear phenomena. From the nucleus everything takes place. Alright. Now the nucleus before any disintegration, before emission of alpha, beta and gamma are known as the parent nucleus. Alright. And parent nucleus we generally denote it by X. We write as usual, we write the atomic number to the left down corner and write down the mass number above. Alright. So what is the name of the nucleus before any decay or before any disintegration? Parent nucleus. Alright. Now from the parent nucleus when any decay takes place, there may be alpha, decay means emission of alpha, beta or gamma, it emits, then there will be a change in the nucleus. Alright. And nuclear, already I discussed this topic, that nuclear change produces a new substance. Alright. So what will happen? A new nucleus will be produced. Now that new nucleus produced after the emission of alpha, beta and gamma, known as the daughter nucleus. Be very happy, all daughters. It never called as the son nucleus. It is known as daughter nucleus. Alright. And daughter nucleus generally we denote it by Y. X we denote for parent nucleus, before emission the nucleus, and after emission the nucleus is known as the daughter nucleus. Alright. Now we know that whenever alpha decay takes place, so one can show like this, put an arrow, then alpha decay takes place, means you are getting one alpha particle. So how to write alpha particle? Already I discussed that +2 because it has 2 charges, 2 proton, and what is the mass number? 4. Alright. Now what will be the daughter nucleus? Daughter nucleus, it is denoted by the symbol Y, but now the question is what will be the atomic number and mass number? In this case, remember, when alpha decay takes place, then what is happening? From the nucleus, 2 proton and 2 neutron, they are combining together and forming the alpha particle and coming out. So you see, what will happen to Y? Its proton number, it will decrease by 2. So Z minus 2. What will happen to the mass number? From the nucleus as a whole, 2 proton, 2 neutron emitted. So it will be 4. So A minus 4. Is that clear? So this is the way alpha decay is represented. So remember, whenever alpha decay takes place, then Z means atomic number. It decreases by 2 and mass number decreases by 4. So this is the important thing you have to remember, and this is the equation, nuclear equation representing the alpha decay. Just look at the daughter nucleus, Z minus 2, A minus 4. Now I will teach you another very important point related with any nuclear reaction. All of you know how to balance the chemical reaction, isn't it? What you do in a chemical reaction, you make number of atom of every substance is equal from the left side and right side, isn't it? And that is the way you balance the chemical reaction. In case of nuclear reaction, we balance it by means of the atomic number and mass number. Remember, the total atomic number on the left hand side of the reaction should be equal to total atomic number on the right side of the reaction. In the same way, total mass number to the left of the reaction should be equal to total mass number on the right of the equation. So look at it, Z minus 2 plus 2. How much is the total atomic number? Z. And what is the atomic number to the left? Z. Alright, now consider the total mass number. A minus 4, then it is 4. So A minus 4 plus 4, how much? A. And what is the mass number on the left side? A. So you see, it is a balanced nuclear reaction. So this is the way we balance the nuclear reaction. Means the atomic number on both sides, total atomic number should be same, and total mass number on both sides should be the same. So that is the way. So according to that, during alpha decay, what happens? Z decreases by 2 and A decreases by 4. You may get a direct question that what happens to atomic number and mass number during alpha decay. Then this is the direct answer. Z decreases by 2, A decreases by 4. Or you may get any kind of equation related with the alpha decay. Alright? Then you must apply this concept. Clear? Then next one is beta decay. Now beta decay, beta particle means what? Already I discussed it, but I am just repeating it so that you can remember it, recall it. Beta is the electron emitted from the nucleus. So as we know, inside the nucleus there is no electron. So where from the beta particle or the electron is coming from the nucleus? Before the emission of beta, this reaction takes place, this transformation takes place within the nucleus. What is the transformation? I am repeating it. One neutron has charge 0, mass 1, converted into one proton has charge plus 1, mass 1, then beta particle is electron, so charge minus 1 and mass 0. And what is the name? I hope you can remember, antineutrino. What is this? This is antineutrino. Always beta particle, emission of beta particle is associated, okay, accompanied by, and beta particle always accompanied by antineutrino. Never you will see that beta particle is emitted alone. Never it happens. Okay. So beta particle always accompanied by whom? Antineutrino. Anti term is there. That's why you see above nu one bar sign is there. Alright. Now what is happening? You see. So if you consider the parent nucleus before the emission, it will be ZXA. Now one beta particle emitted. So minus 1, 0. So here you see what will be the daughter nucleus. Daughter nucleus, just see here, the parent nucleus has Z number of proton. Okay. I hope you are getting it. How many proton the parent nucleus has? Z. Now, when a beta particle emits, then you see what is happening. One neutron converted into one proton, beta particle, antineutrino, beta and antineutrino coming out, proton is staying back. So you see for daughter nucleus, one beta particle means one proton extra it will be. So what will be the atomic number of Y? Atomic number of Y will be Z plus 1. Why this plus 1? Again I am repeating. One beta particle leave behind one proton within the nucleus. Or other way say, one neutron converted into one proton. Now you see what will happen to the mass number. Mass number will remain the same. Why? Because neutron is converted into proton, but mass number is total number of neutron and proton. So total number of neutron proton not changed. Alright, so what will happen? Mass number will remain the same. So this is physically you have to understand it. Then what you can write during beta decay, what happens? Z means the atomic number increases by 1. Increases by 1. But what happens to the mass number? Mass number remains the same. Is that clear? Very interesting, no? During alpha decay, what happens? Z decreases by 2, A decreases by 2. But during beta decay, what will happen? That Z increases by 1, but A remains the same. Now, this one, that why the daughter nucleus is having atomic number Z plus 1, mass number A, that I have discussed, means considering the nuclear reaction that is taking place within the nucleus. But if we consider that the conservation of Z and A on both sides of the nuclear reaction, then also see, as it is -1, then if you consider it Z -1, then what will happen? Z -1 -1 Z -2. But what it should be? It should be Z. So that way also it is coming Z plus 1, because Z plus 1 minus 1, how much? Z. Then you come to the mass number A plus 0. A plus 0, how much? A. Alright. So this is the way this is the nuclear reaction which is representing beta decay, and during beta decay what happens? I repeat once again, you must learn and remember it. Very easy to learn and remember, and very easy to handle also the numericals, the nuclear reactions related with alpha and beta decay. So I request all, especially those who are very much interested in studies and they never study at all, for them also to handle this one is very easy task. So that's why please do remember what happens to alpha decay and beta, what happens after alpha decay and beta decay to the parent nucleus. So for beta decay, Z increases by 1 and A remains the same. Then next is coming gamma decay. Now next is coming gamma decay. Now how the gamma decay? I told you that gamma decay means gamma ray is nothing but electromagnetic radiation, just like light ray. Alright. Now the question arises that from the nucleus how an electromagnetic radiation is coming. Okay. Now you have to understand that. As we know that electrons can stay at different orbits, and orbits are having different energy level. Alright. Like that, nucleus of an atom also can stay at different energy levels. So all these lines I have drawn, what are these? What are they representing? They are representing the energy level of whom? Energy level of a nucleus. Now you see the lowermost level, which is having the lowest energy, the minimum possible energy, is known as the ground state. And if you consider the other energy state, they are having higher energy than the ground state. Okay. Now what is happening? If you consider the nucleus, it is in the normal state, then where the nucleus stay? Nucleus generally stay on the ground state. Alright. Now when the nucleus anyway it gains extra energy, most of the cases they may gain energy due to alpha and beta emission. So what happens when the nucleus that gain extra energy, then they jump to the excited state. So suppose the nucleus has jumped to this one second excited state. This is the first and this is the second excited state, third, fourth and so on. And this one is infinity. So you see, when the nucleus got the energy, it gone to the excited state. But the nucleus cannot stay in the excited state for long time. Alright. Nucleus, molecules, all of them like evenly. Suppose, consider this example. Suppose you have got some extra money. Bua has come, Mosi has come, Nani has come, given you some money. Then the moment you gain the money, then you think, okay, I should have a chocolate, I should have ice cream. So what you do? You go out from home. Alright. So you see nucleus also got the extra energy from Nani and then jumped, gone out of home. But what you do generally? You spend the money, you eat gupchup, ice cream, and you whatever money you have got, you spend it. After spending all the money, then what you do? Then you remember your home. Again you come back to home, isn't it? So you see here, the nucleus do the same thing. The extra energy what the nucleus will do, if it jumps to the ground state, it will emit the extra energy in the form of electromagnetic radiation. This is the waveform. Means this is the electromagnetic radiation and come to the ground state. But it is just spending its extra energy in the form of emission of a gamma. So here you see, you will get one gamma ray. Now the nucleus, it may do like this. It may come here first. So one gamma ray you are getting. Again from here jumping to the ground. So again you are getting gamma ray. So this is the way gamma decay takes place. So you see, when the gamma decay takes place, the nucleus only jumping from the excited state to the ground state. Alright, and no way it is related to any number of proton or neutron, because the ray, gamma ray, is an electromagnetic radiation. It is not having particle nature only. So, how we represent the gamma emission? So, you see, when I am writing gamma, it will write 0, 0, y. Neither it has any neutron, proton. So, atomic number 0, mass number 0. So, what will happen to the daughter nucleus? Daughter nucleus will have nothing, no change in Z and A. But you see, if you write this way, then it is not representing the exact fact of the gamma. What is the exact fact of the gamma? This one, the parent nucleus, it is having extra energy. It is having in excited state. So that we denote by putting an asterisk above the parent nucleus. And in the daughter nucleus, we do not put the asterisk. Why? Because daughter nucleus means the nucleus on the ground state. Alright? So, very carefully you observe that whenever gamma decay reaction will represent, then don't forget to put an asterisk above the parent nucleus. What does that asterisk represent? It represents that parent nucleus is in excited state, means having extra energy. They are not on the ground state. But when you are considering the daughter nucleus, because daughter nucleus and parent nucleus identical Z and A they are having. But what is the difference? That daughter nucleus energy level is minimum. Minimum energy it is having. It is on the ground state. But parent nucleus, it is having more energy, extra energy, and it is in the excited state. So, during gamma decay, so this is the reaction, how to represent gamma decay. And remember that Z remains the same, means there is no change. And A also remains the same. Alright, now this topic I have discussed, this is very important for your all kind of exam. This concept is very important. So please do remember it. So I am repeating, during alpha decay, what happens to Z and A? Z decreases by 2, A decreases by 4. During beta decay, what happens to Z and A? Z increases by 1, A remains the same. And during gamma decay, the most easy one, Z and A remains the same. Don't forget to put the asterisk to represent that parent nucleus having extra energy. Don't put asterisk here. Why? Because the daughter nucleus is on the ground state. So that's all about the alpha, beta and gamma decay. Now, few important concept related with the alpha, beta and gamma decays. Remember that whenever from a nucleus alpha, beta, gamma emission takes place, then it never happen that alpha and beta coming out together. No. 2 alpha coming out together. No. 1 alpha at a time. 1 beta at a time. Is that clear? Means one alpha particle is coming out, then again one alpha particle coming out, then it may happen that one beta particle coming out, but it will never happen that both are coming out together, alpha and beta. And remember, always alpha beta emission may be accompanied with gamma emission, because when alpha and beta emission takes place, then due to that alpha and beta emission, the nucleus gain extra energy. Then nucleus may be lifted from the ground state to the excited state and cause gamma emission. Is that clear? And another point you must remember during radioactivity, that no one can say that at this moment from which atom the emission will take place. Any atom may decay at any time. Alright. So these are all basic concepts related with the radioactive decay. Okay. Now next topic is uses of radioisotopes or uses of radioactivity. Very important topic. That's why I have written point wise how you should write down your answer in exam. Okay. Now first use of radioisotope is in medical science. Radioisotopes are used frequently. Alright. Now the first use, you know that leukemia, cancer, these are very dreaded kind of disease. Alright. Now to treat this cancer, leukemia, radiotherapy is used. The name of the process is radiotherapy. therapy. Alright, in that one, what is done, that gamma ray emitted from cobalt 60, it is used to detect, it may be used to detect cancer, or it may use to kill the cancerous cell. It just, gamma radiation, what it does, it simply burns. Because its penetrating power is very high. You already know the properties of gamma ray. Penetrating power of gamma ray is very high. That's why for normal living being, gamma ray is very dangerous. But for a patient suffering from cancer, this gamma radiation, exposure to the gamma radiation, what it does, that gamma radiation burns, kills the cancerous cells. So radiation emitted, that's why I have written in short, gamma ray from cobalt 60 are used to treat cancer. How the treatment is done? Simply that cancerous part, on the cancerous part, gamma radiation is allowed to fall, and the doctor they control the intensity of the gamma ray depending on the stage of the disease. And what have the gamma rays do? That gamma rays simply burn or kill the cancerous cell. So that details you don't have to write, only this much is enough, that gamma ray from cobalt 60 are used to treat cancer. Here it is using to treat cancer, and the process by which it is done, that is known as radiotherapy. Alright, then another one is that that sometimes it happens that brain hemorrhage takes place, or due to some problem, blood getting clotted in some part of the heart, some part of the blood vessel, which is very dangerous, isn't it? Not only that, tumor you may have inside the brain. In that case, what we use the radioisotopes. This name of the radioisotopes, everybody should learn and remember. Radio sodium chloride, that common salt is made up of sodium chloride. Alright, sodium, that normal sodium is used. But when the radioisotope sodium is used, then it is known as radio sodium chloride. Radio iron, radio iodine, this radio sodium chloride, radio iron, radio iodine, they are known as stressors. Okay, they are used for diagnosis of suspected brain tumors and blood clots before they become dangerous. Alright, another use of these tracers is that the tracers are also used to study different system of the human body. Alright, so the second point related with the tracers are also used to study the natural processes in the human body, just like blood circulation. Now, if you want to study the blood circulation, then what is done? That radiosodium chloride, it is injected with the common salt within the body. Then it gets circulated with the blood in the entire body, and then you can study how the blood circulation taking place at different parts of the body just by following the trace of the radioactive radiation left by this one radiosodium chloride. Alright, so these are the medical uses of radioisotope. Now I will rub the board, but please girls, I request here, I have written point wise how you can write down your answer in board exam without leaving any key word. Then the third medical use is that gamma rays emitted by radioisotopes are used to sterilize bandages, dressing and syringes. Sterilization means what? Making them germ-free. You know that any equipment, when it is used for operation of different parts of human body, then it should not have any germs. So generally the germ-free, how it is done? That you may keep all the apparatus in the boiling water. Okay, by heat, generally we can kill the germs. Okay, but that process is a very lengthy process and not at all cheap and not at all convenient or reliable. Alright, why? You see, because when you are putting all the apparatus in the boiling water, you have to leave the apparatus within the boiling water for some time. Alright, and not only that, when you will take out from the water, or it may be steam also, then also what you have to do, you have to completely dry up the apparatus. If any amount of water is present, then that may be harmful for the patient, isn't it? So, or they may cause the rusting in the apparatus also. So that's why this one sterilization can be done. Sterilization means what? The killing of germs. Killing of germs can be done by using the gamma rays, because gamma ray will, when this syringes, then bandages, then the dressings, they are exposed to the gamma ray will kill the germs present on it. Now, killing the germs, sterilization by gamma ray is 3 points are there. They are cheaper, they are reliable, because they definitely will kill all the germs, and very quick one. Okay, the process is faster, and the process is a reliable process, and the process is cheaper process. Okay, so that's why gamma rays are used for sterilizing purposes. So these are 3 medical uses of radioisotopes or radioactivity. Next is, radioisotopes are used in scientific purposes also. That is the scientific use of radioisotopes. Now first, radioisotopes generally we use that alpha particle scattering. You know that how Rutherford estimated the structure of an atom by alpha particle scattering experiment. Alright. So alpha particle scattering helps in estimating the size of the nucleus, and it also helps in understanding the nature of nuclear forces. Alright. And alpha particles are also used as projectiles for nuclear reactions. Means if you want to bombard and if you want to break any nucleus, in that case alpha particle, highly energized alpha particles are used. So that's why it is alpha particles are also used as projectiles for nuclear reaction. Then second one is very important. If you want to find out the age of any archaeological material, means some rocks, plants, anything buried deep inside the earth for long time, even you can find out what is the age of earth by using the carbon dating process. Carbon dating means what? From the radioisotope of carbon, when beta decay takes place, then it is converted into the nitrogen, it is converted into C14. Means this is a long one, that method you will study in details in 12th standard itself. So just remember the name of the process. By using the process carbon dating, one can estimate the age of rocks, earth, plants. Alright. And carbon dating means what? The study of rate of decay of 6C14 by beta decay. And the third use, that radioactive tracers are also used in agricultural science to study the growth of the plant. Then certain radiophosphate they are used, and where the radiophosphate are going, what kind of reaction they are doing. By studying all these things, you can study the growth of the plants in agricultural science. So these are the 3 scientific uses of radioisotopes. You must note down point wise and kindly learn it, because these are no numericals are involved within it, and very interesting point they are, so easily you can learn and remember the points. Next important use of radioisotopes are industrial use. Now already you studied that inside the nuclear reactor we use the uranium rod as the fuel. Sometimes we use plutonium also. So this uranium 92-235 and 92-238, they are used as nuclear fuel for nuclear reactors. Now radioisotopes are also used to control the thickness of paper, plastic and metal sheets during their manufacture, and this is used by using, means this is determined or controlled the thickness of the paper, then metal sheet or the plastic during their manufacture by using the penetrating power of beta rays. So that is the second point, that radioisotopes are used to control the thickness of paper, plastic and metal sheets during their manufacture. Here within bracket, don't forget to mention that penetrating power of beta is used. Then third one is ionization effect of radiations from the radioisotopes are used in making the luminescent signs. You will see that in the malls, certain signs are there that in absence of light also you can see that it glows. They are the luminescent signs. That luminescent signs are produced by the ionization effect of radiation emitted from the radioisotopes. Then next one is radioisotopes are used by the engineers in the factories to remove the accumulated charge on the movable parts of a machine due to friction. Now what the radioisotopes, the radiation emitted from the radioisotope, what they do? They ionize the air surrounding the machine. So when they ionize the air, then what the ions they do? They just carry the charge accumulated over the movable parts due to friction. So these are the 4 points related with industrial use. So the medical use, scientific use and industrial use, everybody should learn, practice.